Okay, good morning, everybody. Once again, my name is Michele De Nigris. I am the lead of the Transition Initiative number 1 of the Clean Energy Transition Partnership. And I welcome all of you to this event where we are going to present the call module number 1 for 2023, dedicated to direct current technologies for the power networks. First of all, let me recall what the Clean Energy Transition Partnership is, because several of you may not be completely aware of the structure, of the aim, and of the potential of the Clean Energy Transition Partnership. First of all, this is a multilateral and strategic partnership of nations, national and regional research, development, and innovation programs in the EU member states and in also the associated countries. We support the Strategic Energy Technology Plan. We support its objectives, and we support as well the Repower EU plan. What we want to do is to help achieving a climate neutral society by 2050, diversify European energy supplies, and we also want to strengthen Europe's clean energy value chains, making them more sustainable. What do? We build on existing set plan initiatives, the implementation working groups, the European Technology and Innovation platforms, the ERANETs, and so on. And we want to create synergies between the National Energy and Climate Plan and with the Recovery Resilience Facility. So what do? We pool national and regional funding for the broad variety of technology and system solutions that are required to make the energy transition. And so we bring together national and regional financing with a top-up from the European Commission. We are aiming at the transition given by the industry together with public institutions, academia, and research groups. So leveraging the local aspects with the global and European aspects, and also with the international aspects intended as also outside Europe, because we have a specific whole module that is dedicated to mission innovation, which is not going to be dealt with today, but it will be the subject of a future webinar. The Clean Energy Transition Partnership gathers 30 countries. We have 55 founding partners, and we have the gathering of national and regional funds with a top-up from the Energy Commission, and this is really the biggest financing organization. This has started in 2022. The first call was last year. During the call of last year, we have gathered the projects for a total financing of nearly 100 million euros. So this is quite a big initiative. The Clean Energy Transition Partnership is organized into different so-called transition initiatives. The transition initiatives are thematic technological configuration inside the partnership, looking at specific aspects of the strategic research and innovation agenda. There are 7 transition initiatives which address the different CETPartnership research and development initiative challenges as they are described in the strategic research and innovation agenda. You see the list of the different transition initiatives in this slide. We are going to focus on TRI1 on integrated net zero emission energy systems, but we also have enhanced zero emission power technologies, looking at generation technologies. We have an initiative dedicated to storage and to CCU, CCS. We have an initiative dedicated to zero-emission heating and cooling solutions, regional energy systems, industrial energy systems, and the built environment. So you see that all the aspects of the technologies that are necessary for the energy transition are considered in the Clean Energy Transition Partnership. The Transition Partnership, the Transition Initiative number 1 is dedicated to an optimized, integrated European net zero energy system. Its mission is to develop the optimized, integrated European net zero emission energy system. So not only electricity system, but the entire integrated energy system, where, of course, the electricity distribution and transmission systems are seen as a backbone for the future low-carbon integrated energy system, with very close integration among all energy carrier networks. So electricity, gas, heating and cooling, water, and, of course, with a lot of digitalization. We want to achieve a higher level of circularity, energy efficiency, greater direct electrification of end users. And so we are looking at also the electric mobility and the electrification of the end use application in the TRI1, not specifically in this core module. We also want to integrate renewables and low carbon fuels for end use applications that are, of course, more difficult to be electrified. So the so-called hard to abate sectors. So let us look at the TRI1 core module for 2023. As I told you, we are focusing on direct current technologies for the power networks. So here our focus is mostly on electricity and on the integration of electricity with other sectors, but more focusing on the direct current technologies. So the aim here is to accelerate the high voltage DC and the medium voltage DC deployment, both for offshore application, HV, but also for onshore application, looking at also medium and low voltage distribution. We want to look at aspects of operation, control, and protection, enabling and supporting tools for example, the integration of energy islands or for hybrid networks. We want you to propose projects that leverage existing initiatives, looking at verification, testing, maintenance, control, and protection, as I said before. We want, of course, that your proposals fit into the roadmaps and the strategic research agenda, in complementing Horizon Europe calls, complementing big projects, or fitting into research roadmaps. As much as possible, we would also like projects that look at planning and markets. So coordination and integration of meshed energy islands, for example, in hybrid AC/DC networks, as an example. So let us go a little bit more into the detail for that. So the TRI1 core module, as we said, wants to accelerate high voltage and medium voltage DC. We all recognize that DC grids are becoming always more important for both long distance transmission through high voltage DC, also with the possibility to connect energy islands, because the underwater, we can say HVDC is I can say the only technology to connect long distance offshore applications. But we also want to stress on the opportunities of medium voltage and low voltage DC networks, looking at microgrids empowered by power electronics and these types of development. The final aim is to enable grid operation technologies at high voltage, medium voltage, and low voltage level on top of the converters, because we think that this is very much necessary. So not only the converters themselves, but also all the supporting activities for verification, for validation, for testing, for studying of technologies and their integration. So we want you to propose projects in which you work with the test facilities, with hardware in the loop. We want you to develop and to propose support, control, and measurement tools, acting in a complementary and integrated way with respect to other Horizon Europe calls and big projects, because the projects that we are financing are not going to be very big projects, but we want you as much as possible to build on existing projects and initiative fitting into the research roadmaps, for example, of the ATIPs, ATIPsNet, ATIP Wind, implementation working groups on high voltage DC, implementation working group on integrated energy systems, and so on and so forth. So what we are looking at is the possibility to enable scaling for verification of operation, testing of individual components, detection and clearance of faults, as well as an easier maintenance of all the level of DC applications. We want you to show the benefits of hybrid AC and DC grid with pure grids, whether onshore, on or offshore, by means of analysis of DC microgrid, which is also acceptable. We want you to provide also practical advice on how to integrate energy islands and conversion of infrastructure, which can be done in a sustainable way with an environmental impact as low as possible and with costs as low as possible. So you see that the scope of the call is extremely broad. We started in continuity with the 2022 call modules, enlarging the fields, leveraging the knowledge and the results that have arisen from the 2022 projects on planning tools and flexibility technologies, because last year the call was essentially dedicated to flexibility technologies and planning tools. But we want to add technological perspectives in the field of DC networks and also energy islands. We want to work in an integrated and complementary way with respect to outstanding Horizon Europe projects, as I said, contributing to the achievement of the Clean Energy Transition Partnership strategic research agenda. So look at the high voltage and medium voltage and low voltage DC in your proposals, with the development of testing and validation of solutions, with the development and proposal of tools and methods, for example, for fault management and maintenance, with the sustainable and efficient integration of energy islands as examples. The budget is of about 10 million. We plan to finance 2 or 3 projects, probably with 2 or 4 million per project. We ask you to give proposals not with any specific technology readiness level, but we want you to prove the fact that your project can help in achieving a jump of one or two technology readiness level classes. Your project, when financed, is not going to be a project in isolation. It is going to be a project that is going to be very closely integrated into the Clean Energy Transition Partnership knowledge communities. We are building up this knowledge community and the impact group, fostering on information and best practice exchange among the different projects, but also with a much wider community, guaranteeing the fact that the results of your projects, when financed, will reach European and international levels and will be part of an overall discussion and a solution-oriented community. The participation in the knowledge community is an intrinsic part of the project. So you are going to be asked also to devote attention to the participation of your proposal, of your project, into a knowledge community and in the activities that are going to be organized by the knowledge community and by the funding partners. This is going to be organized and structured into digital collaboration platforms that include working groups, the development of living documents, joint communication and dissemination activities, and so on and so forth. So you are going to be part of an entire community of projects. Another aspect which I think is of importance, the Clean Energy Transition Partnership wants to be an initiative that goes a little bit beyond the technological development. This is why, in accordance with what has already been done in the ERANET Smart Energy System, we want as much as possible the proposals to adopt the so-called three-layer research model. This means that your proposals are going to be better evaluated if you do not only have a technological focus, but if you also add to your approach marketplaces. So how do you organize the application of your technology by means, for example, of living labs, sandboxes, business models, regulatory frameworks, and so on. And also if you add transition levels. So how and why do you make this technological development, and what is in for the community, the society, the policy, and the education? So as much as possible, we would like you to develop proposals that go a little bit beyond the technology, but that also address aspects for, we can say, the entire society. So this is the general framework of the call. The call text is already available for you to read and to study. I think that most of you will already have read the document. And let us go now to the agenda of today, to the second part of the agenda of today. The day has been organized for you in two panel sessions and an additional session that will give you more insight about the technicalities of the call procedure and the funding mechanisms. And we will have as well a question and answer session. So let us start now with the first panel. I hope that my panelists are there. The first panel will look at aspects dedicated to high voltage DC mostly. And we have three participants from three points of view and three stakeholders, we can say. So let me interrupt my screen sharing and come back to the general application and general vision. So I see already on the screen two of my panelists. I hope that Dirk also is connected. So if you can show yourself, Dirk, if you are connected. Otherwise, I am in trouble. Do we have Dirk van Herten?
Sorry, Michele, it seems that Dirk is not already here, not yet. We actually are 2 minutes earlier. So maybe...
Oh, that's very good. Yes.
Maybe we can wait some minutes.
In the meantime, I would like to introduce the two panelists that are already connected. So thank you very much for joining us. Good morning to both of you. We have Nuno Sousa e Silva, who is Managing Director of R&D Nestor. That is a research center owned by the Portuguese TSO. So Nuno will represent as well the European Technology and Innovation Platform on Integrated Energy Systems, so the ETIP-SNET, where he is co-chair of the working group number 1 on the development of an efficient and economic energy system. And on the other side, welcome and thank you for joining us. We have Peter Sanderberg. He is Global Product Manager HVDC at Hitachi Energy, and he also represents here the European Technology and Innovation Platform on wind, so the ETIP Wind. So for the moment, waiting for the third panelist, we have the representative, we can say, of a transmission system operator, or in the framework of a transition system operator. We have the representative of a manufacturer, and we are really waiting for the participation of Dirk van Herten. He is a professor at KU Leuven, and he will represent for us the aspects of research, and here he is. Dirk. Dirk, good morning.
Morning, sorry for being just at time.
You are right in time. Thank you very much. We are now starting the panel. So I will introduce then Dirk van Herten. He is professor in KU Leuven. He is director of HVDC Competence Center in Energieville in Belgium, but also he is a co-chair of the CETPlan High Voltage DC Implementation Working Group. And he represents here in this panel, he represents somehow also the academia and the research community. So thank you for being with us. First of all, if you want to say a few words already before we start with the discussions, so bringing perhaps the importance of HVDC for the sector that you represent, and then we will go with more specific questions. Nuno, would you like to begin?
Yeah, very good, Michele. Yeah, thank you very much for the introduction and for the words. So welcome everybody, and I hope that you are all enthusiastic with the participation in this Clean Energy Transition Partnership. It is in fact an interesting initiative that I have been following since last year, since its inception, and so I believe it promotes very interesting possibilities to promote projects in different areas. So today we are here to talk about TRI1, the one that Michele just described, which is very much focused on HVDC. Or not only on HVDC, let's say, it's DC in general, because it goes from, let's say, a higher level application in terms of voltage, but also to medium and low voltage DC, which is becoming increasingly important in Europe and in the context of the energy transition. So I believe it's very timely, very topical, and it is very broad in terms of topics. I also prepared a couple of slides just to highlight some keywords. And as Michele said, so not only I have here a bit the hat of a transmission system operator, crucial for HVDC topics, because I understand this first panel will address more high voltage and the second panel will address medium and low. So I will focus more on the high voltage aspect. So TSO related, very important. In particular, started in two areas. One is the connection of offshore wind farms, large and massive integration of renewables, starting in the North Sea, but going a bit everywhere now. So that is, let's say, that one of the first applications. But we see that also coming into mainland, and in particular, where there are mismatches between load and consumption. You can see the case in Germany, north and south. You can see also in Italy along the coast. And the solutions can be via overhead lines or via cables in different applications, submarine cables. So there is a lot to address here. There is a lot of electronics in the grid, which makes some implication in terms of dynamics and behavior and quick reaction of the system operation, let's say, which creates challenges for a TSO or for a system operator. So exciting times from the engineering point of view, challenging times from the problem solving point of view, but I think they are all very much relevant. And so I will probably have time to address topics that go not only from the planning point of view, but from the operational point of view, monitoring point of view, SCADA tools and control center, very relevant, how the electronic relates because of the lack of inertia in the system, because you have more electronics also on the PV side, you have electronics on all the converter related assets and batteries, and so a lot of changes, let's say, in the behavior of the grid. So just to give you some enthusiasm about the topic, there is a lot to do here, and probably pass the word also to my colleagues to give us some initial words.
Thank you very much, Nuno. And yes, I would go to Dirk if you want to give us a very, very short highlight also of the work of the implementation working group, because I think it is important that through the implementation working group also you represent, somehow you gather member states to discuss about the future of high voltage DC.
So thank you for the opportunity to talk here. I have some slides, but I will not show them today. So what I think is important is we need to recognize that there are giga investments necessary at a very short time frame. I think you can compare it to what happened after the World Wars, that we had to rebuild our power system. But now we need to build a system that is roughly 3 times bigger in 30 years' time. So we need to triple the system. I like, by the way, the picture that you have behind you, Michele, about from The Economist, because I think everyone is getting aware that these investments are critical to have a sustainable future energy system. Still, there are lots of uncertainties, and we don't have the technology to build this supergrid. I don't think the power ratings are there. We have lots of operational questions, planning, control and protection is unsure. These converter systems that we want to deploy, they're far from perfect, and there is a software issue to develop as well. And then on top of that, we also have these practical things. I know I'm an academic, but it's important to talk about the supply chain, and in order to make that go easier, so both in the people that we have available to do it, but also in the processes, we need to think about better maintenance procedures, more standardization. We need to think about all the effects that will make the costs go down. It's not just that it works, but it's pretty expensive, and even in the low estimates, we talk about trillions. But that being said, this is a European technology, and I think it is incredibly important to also invest in that European technology as DC technology. And if we need trillions, and let's say that you have 1% of those investment needs that you would put in R&D, which is actually not that much, I'm quite sure that we get a multiple of that in return in social welfare in the long run. So there is a massive R&D need at the moment in this technology that will realize a super sustainable future power system. Now, with the SET, we have identified in our first implementation plan a number of R&D topics which we believe are critical to be done in the next on the short-term, mid-term, and long-term horizon. And we have focused them on what is the technology needs, what are the control and protection needs, the operational and the planning ones. And we're inviting everyone to participate in these exercises. We're going to do a second round soon to update our implementation plan, because there are, like I said, significant R&D needs in this technology. Is that?
Thank you, Dirk.
Thank you.
We will come back to you with then the different topics of the panel. Peter, the word is yours for a general introduction, and then we will go to the questions and the organized panel.
Okay, thanks a lot. Yes, just let me introduce myself first. My name is Peter Sanderberg, and I'm the Global Product Manager for Offshore Wind Connections at the Hitachi Energy. And just to be a bit clear on my role here, of course, I know what ETIP is, and I'm in close contact with discussions with regards to European development and so forth, but I wouldn't say that I'm a good representative of them. I would rather see this possibility as well, giving me this possibility to be a voice from the industry. I meet with the industry more or less on a daily basis on potential clients and different organizations, and we discuss the possibility with this HVDC technology. I started my career with ABB already at the Stone Age, which as my kids would refer to, but in 1988, so I've been there for quite a while, and I've been attending the offshore wind business in 2005. So I've seen the development coming and progressing. I did pull together 3 slides to share with you if I'm allowed to. I'm not sure if this is the time or if we should take that later on, Michelle.
That is fine. Then we will go on with the more organized discussion. But that's fine. Please, you're free to do so.
Okay.
We are flexible by definition.
That's great. Let me just see if I can share the screen here. And share. So let me know if you can see the screen.
Yeah, we can perfectly.
Perfect. Good. So as I said, we've been in this business for quite a while, and we got our first HVDC offshore wind connections. Got the order in 2007, so that's becoming some time now. And just very shortly, as you can see, and you're probably aware of, the HVDC technology is used in many different applications. And I will, of course, not go into all the different variants, but I would like to emphasize that the applications or the way where we use it, they are all based on the same technology. And this is, of course, how we gain experience, achieve economy of scale, and are given opportunity to continuously improve and perfecting our quality. But back to offshore wind, and I just wanted to take this opportunity to share with you what is discussed in the industry, so that you get so this is more or less a snapshot of what's going on, and it's of course not possible to cover all these different topics in 15 minutes or so, but let's take a look of some of them and allow me to share with you some areas where I believe that we as an industry need to come together and explore further. So when I started this offshore wind business 18 years ago, I mean, radio connection was and still is, as a matter of fact, the only way to integrate large-scale offshore wind energy. This is how it was. But today we're at the point where we start to discuss how to best optimize transmission infrastructure. And one way that is discussed a lot in UK, but also to some extent in mainland Europe and a lot in US, even though I know this is European forum, let me refer to US sometimes, is to have some kind of AC, I call it backbone, but some kind of AC system connecting different wind farms. There are, however, some challenges with that, and this is where I would land at where we need to study further. And one thing is the risk for cascading trips and the need for so-called shopper. Sorry for being a bit technical here, but this is a major thing that needs to be carefully studied, because it is a risk that if we just connect it like the drawing indicates here, that we get cascading trips and we will jeopardize the full system integrity, and in worst case the grid, the onshore grid. We have the issue with regards to resonances and harmonic filters should be studied, has to some extent been studied, but needs to be looked into carefully, because if we start to think about the details, there are a number of configurations that we can have in the wind farms, and when we kind of combine them, then we get some real tough challenges. One should know that the wind farm can be modeled as an impedance with inductive impedance and the cable capacitance, and then we have the HVDC also as an inductor, and then of course that's the perfect resonance circuit. So that needs to be looked into, and also when it comes to the converter interaction and voltage and frequency coordination. So that's one thing. Another way to go is, of course, to work with multi-purpose interconnections. Sometimes we call them multi-terminal, different name, but basically from a technical perspective, it's a little bit the same. And of course, there are things that needs to be looked into there. First of all, if we don't consider the system as one protection zone, but several protection zones, then we need to have some kind of circuit breakers. If we would like to have the different converter stations from different suppliers, then we need to fix the issues with interoperability, and this is far from a technical issue only. It's a lot about regulatory schemes and aspects to consider, and of course control mode. And last but not least, the more futuristic vision, perhaps meshed grid, and we can start to discuss what are the major challenges there. Of course, a mesh grid needs to be gradually developed and expanded, and expandability, that is something that we need to understand better than what we do today. Power flow controllability, there are voices in the industry stating that along with the increased complexity or the number of nodes, we will have less controllability, and of course then the value that the grid will provide will be less. And again, regulatory challenges: who would own the net, who would operate the net, and so on. So this was basically my short introduction, Michelle. I will stop presenting here.
Thank you very, very much, Peter. And I think that when we have started to think about the Transition Initiative 1 call module for this year, looking at high voltage DC, we were a little bit worried by the fact that, guys, Dirk has told us that we need to invest trillions of euros for the development of the infrastructure. We are dedicating, because this is a national budget that is then topped up by some European budget, but we are looking at somehow smaller projects. So how are we going to address our we can say partners in the Clean Energy Transition Partnership and our proposers to say, guys, there is a lot to do. These are big money, but we can devote limited, at least, sum of money. So what are we going to propose then? It is not so simple to imagine to build up, and it is not possible to build up a full-scale HVDC connection or onshore or worse, we can say offshore. But what I heard from Dirk on the first side and from Peter on the other side is there are a lot of different activities that need to be developed in research centers, in offices, in computers, in research teams with simulation, with the development of control aspects, with the development of protection system, with the study of interoperability. You have spoken about control coordination, flow control, regulatory aspects and challenges. So I am very much relieved by the fact that really, without investing in these projects of the Clean Energy Transition Partnership, trillions of euros, we can really give a good contribution to the advancement of technologies. So thank you very much to all of you, because I think this is important, and I hope this is well understood also by the public that we have here around the table. So we have seen that there are different aspects that need to be developed, and I would also go a little bit further around. Peter has shown us some slides about his view of the necessary development. Dirk, you have spoken a little bit, but if you also want to go a little bit deeper also on the subjects that you see from the research and development area, I think you will help also our audience to better focus on the extremely wide panorama of potential interesting activities of this call. Dirk?
Yeah, so no, I fully agree with you that although that the investment needs are gigantic, there are a number of items that are realistic in size, and even a small team can start with that. And you mentioned a few, but the main expense in this HVDC big systems is in the primary equipment, which is of course big and voluminous. And if you have big stuff, it's going to be expensive. But you also have secondary equipment and the control side of that, for which you don't necessarily need to spend the millions for a kilometer of cable. So at the secondary side, there's quite a bit of stuff that is necessary. And I'm also thinking in the direction of anything that goes into a more standardized setup and goes into a more efficient management of these future systems, including maintenance management, etc., will accelerate the transition, because the costs will go down. You will need fewer people that are involved in these processes, and you don't necessarily need to have an HVDC station in your laboratory to develop such techniques. It would be nice, and we're happy to talk with Peter whether there is a place here nearby to place one, and we would be interested. But I don't think it's a strict requirement to have that. So Peter, we can talk after the session about that. No joking on that, but also on the software side, I think Nuno mentioned the SCADA side of it, or the hierarchical control of such systems. You need to send signals from a central controller to the different units. You need to monitor the system. It's really a lot of things to do. Actually, it's very scary if you look at what we have today and where we need to go in just 27 years from now. Work for everyone, I think, at all sizes and all in TRL levels. So I'm not worried about finding topics. That's the least of the worries I would have.
Thank you very much. So you make our session very easy, because we are speaking about topics now. So I think there is plenty of choice. Nuno, from the TSO point of view as well, I think there are expectations from this call, because remember that at the end, these projects have got specific targets in terms of need owners. So I think that among the need owners, the transition system operators, and then we will see later the distribution system operators will have to play a role. Nuno?
Yeah, true. Yeah, in fact, that is what I was thinking when we were going through this introduction, putting myself in the shoes of the people who are listening to this and who want to make a proposal. Okay, how should I grab this? Because I cannot do everything. And so what little pieces can I do? And maybe here I can put a little bit, besides the TSO aspect, my ETIPSnet share hat as well, because I'm part of the executive committee there, as you mentioned, in one of the working groups. And so ETIPSnet, for those who are not aware, but it is already also mentioned in the call from the CETP, like Michele mentioned, that you as applicants should pay attention to the initiatives and what is being thought by all these organizations, the IWG and the different ETIPs. So I thought I could share here a bit, if you don't mind.
Yeah, you can, of course.
Michele, a couple of messages, because I think the visual also helps the people around the table here to see a little bit and to have a stronger sense of the messages here. So just skipping this, which is the, let's say, the introduction for this TRI and the motivation that come from the Green Deal, I would just say that the ETIPSnet, being an entity created by the European Commission to support them towards the vision of where R&D and innovation should go for the future. So it's the right place also to look into what these guys here in ETIPSnet are talking. And so they created these 9 big concepts of different directions, from cross-sector to markets, to digitalization, to cybersecurity, all of those. But there are 2 of them which are particularly critical or relevant for these TRI1 in the CETP. There could be more, but I would like to highlight 2 of them. One of them is what they call the high-level use case 4, which is about massive renewable penetration in the transmission and distribution, but now we are talking about the transmission. And so it's all this complexity of having a system with much more DC connections and a lot of power electronics in the system, and the need to start to have some green forming capabilities in the system. So this is something that it is still in the early stage, and so a lot of room here to make simulations, to make here some information, some material about on the electronics side of it, and on the contribution to the system. And so all these grid forming related aspects are very important. And so this high-level use case, which is looking how to integrate and include so much renewables. How can we do it? And HVDC, it's one of the key drivers in that direction. But another one, it's even stronger, which is how do we ensure a secure operation? And now I connect to your message regarding the TSO. TSO main concern is secure operation. And so how do we ensure that we have a secure operation with so much electronic in the system? And so there are a lot of concerns, like Dirk mentioned, that we still don't know a lot of what is going to happen in terms of system operation and how the quantity of electronics in the system will shape the system operation. So that's one aspect that one can look. Another one is like Peter said, the idea of multi-terminal, multi-vendor and meshed grids. Mostly for, of course, offshore operations. And here, as Michele mentioned, I think it's important to notice that with the available budget, you are not able to do things from completely scratch. So look into what is being done in other European projects, like Michele said. He mentioned several of the Horizon projects. In particular, I'm also participating in another Horizon project, which I think is relevant here, which is Ready for DC, in which I'm co-chairing one of the groups there. And in fact, people are looking how to create the first examples of multi-terminal, multi-vendor meshed DC grids. And this has several implications, as I will address a little bit in the few minutes coming up. Grid forming, I already mentioned, and system operation again. So I'm going here for the keywords, technical challenges that you will be facing. So you can look into these bold messages here as grabbing elements that you can bring to your proposal. So is it the electronic background associated with these devices and their fast response, and how to analyze the dynamic response of them? Another one, and related to this one, system stability, frequency, voltage, and rotor angle stability. This is another area that could be addressed, all related also to the lack of inertia in the system, and new tools, how to model these, just to avoid that the models and the tools that we as system operators have are reflecting, and make sure they are reflecting what will happen in the system. Otherwise, it can happen something like it happened in Brazil in August, that the system operator thought that their models were very good and their simulations were perfect for N-1, and all of a sudden something happened and their models did not reflect exactly what was in the field. Not only because the models were black boxes and they don't react exactly as they do, but also because the information was not updated close to the system operator in regards to what was in the field. But basically, tools are needed. Another bullet here, bullet number 5, testing methods. And so how do I create methods to assess reliability of the system? Then another one is, as we progress with these little islands, we will have a hybrid network. And so what in the beginning is just a little bit of bubbles here and there of HVDC, all of a sudden, it's going to be in the horizon of 2030, a meshed grid with a lot of AC links and a lot of DC links. And probably we need to think about new control concepts, because it's not the same thing everywhere. Another one, let me come down to my last slide here, which is like, well, it's again the same thing, focus areas. So dynamics, simulation tools, grid services that we can give, so grid forming aspects I mentioned before, how to address this mesh, the hybrid system, and again, as I mentioned in the beginning, people in the control center and in the SCADA, with the SCADA information, now they will have a kind of two worlds there. And so the AC and DC, but we don't want to have two teams there, and tools for analyzing one and tools for analyzing the other one. So thinking a little bit about how is going to be the control room when these things are present there. Interoperability, because we don't want to be stuck with one vendor. And so we want the different vendors and capabilities to talk to each other. The aspect of standardization was mentioned before. Supply chains, also Dirk mentioned, it's an issue. Legal and regulatory, in particular in the context where we have multi-country issues, because very often these, in particular in the North Sea, you see that the system might belong to different countries with different regulatory aspects and legal aspects. And the last but not least, the market-related aspects and bidding zones creation. What are the implications? So you see that it can go very much from the electronic point of view to a more global and infrastructure point of view, and up to a market level as well. Yeah, I think this gives already a good indication for several of the potential proponents that they can pick one of these and probably they can make an impact in a lot of different areas. So yeah, I think this answers a bit concerns of the TSO, but also for the participants, what can I do to try to contribute to all these giant challenge that we have in front of us. Back to you, Michele.
Thank you very much, Nuno. And I think that with these three presentations and three discussions, we have a very, very wide portfolio of potential proposals. I would, because this is probably something that is also closer, I think, to the aspects that are developed at member state level. A lot of concern about all the aspects that are dealing with interoperability. So the aspects of interoperability, scalability, standardization, I think is keywords that in my point of view should be very, very much in mind of the proposers. And I would personally love to see proposals that somehow address the aspects of the value chains and of the supply chains. Because, and of course, looking at the aspects, when you speak about the supply chains, immediately you go into the aspects of circularity, of modularity, of extending the lifetime of components, and all these aspects that are essentially related to the opportunities and to the challenges of reducing the impact of bottlenecks into the supply chains. So I think these are aspects that need to be very, very closely taken into consideration. So in this very complex round, because I think that some of our persons in the public may have a big confusion in their head now, because we have put on the table so very many different aspects. I would give the advice, and then I will give you once again the word about looking at the value chain of the applications, of the different applications of high voltage DC, as very clearly explained by Peter, looking at the different potential value chains, looking at the different pieces inside the value chain. We have seen that there are needs at every step, we can say, of the value chain, also without considering the bulk investments in terms of converter, in terms of cables, in terms of generators, but all the aspects that are there around, and try to find in a rational way how best your skills, your development capabilities, your laboratories, your hardware, and your simulation skills, possibly applied with hardware in the loop or whatever, can best be applied to these different value chains. So we have 10 more minutes. I unfortunately cannot open to questions from the audience, but I would like to have very small and concise words of call of action from each of you. So you imagine to be in front of potential proposers, what would be the advice that you would give the proposers in terms of how to best build up their proposals in such a way that they are the most impactful in this call. Who starts? Dirk.
Thank you for the opportunity to start off with this. No, I think it is, like I mentioned, there is a gigantic investment need to get towards a DC future system, but not all of it will go to Hitachi. Sorry, Peter, nor the other HVDC vendors alone. They will be an important part, but there is a lot of stuff happening, and don't be too narrow-minded and in what is necessary to realize this. And of course, the technology is very important. But the things that were mentioned by Nuno and Peter and also myself include a vast range of activities that are around this HVDC activities, which are really substantial. Software is a gigantic, there's a gigantic need there. The testing, the auxiliaries, the maintenance and supply chain. So I would say be open-minded, and there is my issue is to choose rather than to say that we are limited here. So you can choose only a few things that you can focus on this call. Next call, you can focus on the next thing. So
good. And how are you preparing to your proposal in the call?
Myself,
I will ask the same questions to the others as well.
I'm in this case. Flanders is the institute is, well, Belgium is a complicated country, and I'm discussing with the Flemish government on how we can actually play a role, but we support the industry in Flanders in this. So any Flemish companies are very welcome to talk to us and how we can help them in addressing this important topic.
Thank you very much. Peter, your turn. Few words, and which ideal partner would you have in the participation to this call?
I mean, first of all, just let me emphasize the thing that has been discussed with regards to standardization and so on. And of course, we do have an unprecedented situation when it comes to the market situation right now. We have a demand side that is far beyond, I would say, what the full supply chain will be able to catch up with. So we are, from Hitachi Energy side, we are investing heavily in expanding our capacity, but that is not enough. We also need to scale our business, and the way to go about it is, of course, to see if we can go in a direction where we are. I mean, to say standardize, I've been in too long into this business to really believe that a full standardization is possible. Every station, every link will be connected to a specific grid. You have different length of cables, different resistance, and so on. So you need to have some level of bespoke design in your construction to be a bit pragmatic here. However, I do believe that there are possibilities to streamline and make a design that can be reused. And I would like to see in the future more software-driven design, actually, that we can use a main circuit that is more standardized, and then we can meet the specific needs or project-specific requirements more on the software side. And it's also important to convey the message that today we're in a situation where we need to look into what features can we provide with our solutions, and what needs do the industry have for specific situation, and where are the gaps. So this is the ride we're into, and I think I would like also to state that PowerPoint engineering is very easy. I mean, I throw up myself a few slides here to discuss them. It's just when you start to go into the nitty-gritty that you find potential showstoppers, and to identify those showstoppers early on, and not to, I mean, if there are principal showstoppers, not to proceed in a dead end. That's important as well, because sometimes there are principal things that we cannot go around, and then we need to find alternative ways. So this is in short summary on where I think it's important to go, to have a pragmatic approach on one hand, to see where we can best scale and benefit from some kind of standardization.
Thank you very much. I think your words are very important to keep the foot on the ground. And also to have an attitude of being pragmatic and close to the application. Why not in relation with manufacturers and with the along the entire value chain and supply chain. I like your expression of PowerPoint engineering. This goes very much hand in hand, where I say that we need to go from PowerPoint to the power system. I think this is very much in line. Nuno, you have 2 more minutes, and then we will close this first panel and take a deserved break for a few minutes. Nuno.
Yeah, very good. So let me be quick, mindful of the time. So I think in thinking about call to action for the participants, and so how can they grab this in a more tangible way? I think one important element is, as you mentioned before, Michele, to address the proposals from the 3 research layers point of view. So the technology, the market, and the transfer. To include that in their mindset when they set up the proposal. So very much in line with the CETP, let's say, mind frame. And then you mentioned, okay, the supply chain already, that one is closer to your heart. So let me pick another one. Let me go to another direction, which is very much in the basis of everything, which is in the modeling and the interoperability aspect that was mentioned before. And I think these nitty-gritty elements are key in order then to move to the other ones. And so for those in particular who are keen on these, all the hardware in the loop simulations, all the modeling, because the proper modeling then allows probably a little bit of interoperability. And then the vendors, maybe they can talk a little bit more if they want, of course. They have to identify where are the frontiers and the IP seats and all that. But if we have good modeling, good capabilities in there, hardware in the loop testing, and also close to my heart and from the system operator, tools in the SCADA system and the control center. Those are elements which are needed for the system to be safe, because we cannot run the risk of let's go and test it and see if it works. Okay, and so I think it's very important that when it goes there, we are stable, we are comfortable, and we know that there will be no dramatic change in risk. And that's why, to avoid risk, I would go with these, let's say, smaller steps, which are very technological, but are in the heart of the success of whatever comes. Thank you, Nicola.
Thank you very much, Nuno. This closes this panel session. I think not only us, but I think our public deserves a little bit of a break. So we are going to break for 15 minutes, so from 11:15 to 11:30. Before you switch off your camera, I again want to thank you very much. I see also Antonio Iliceto, who has joined us. He was also planned to be in this panel session. Thank you very much, Antonio. I see you are in a plane, so it means that you are really making the effort to be one of us. And this is very, very much appreciated. So before you switch on your microphones and before we go to the break, there is a very small film about the transition initiative #1 of the Clean Energy Transition Partnership. And then we will meet again at 11:30. With Chiara Gandolfi, who will moderate the second session, the second panel on medium voltage and low voltage DC. So thank you very much, and let's go to the small film. Thank you again.
We need an optimized and fully integrated net zero emission energy system.
Not only in a particular country, we need it all over Europe.
You and me together, we could be anything.
And not only with one energy carrier.
In such systems, electricity, heating and cooling, water, gas network work together to achieve a resilient and efficient infrastructure.
Networks need to provide the backbone to create the smart, reliable, and resilient energy system of the future.
This, of course, will be possible only if digital technologies and solutions are applied to supervise, control, and optimize the system.
The Transition Initiative 1 Integrated Net Zero Emissions Energy System is addressing this challenge.
Transition Initiative 1 is about integrated energy systems.
It develops appropriate call topics and accompanying activities.
Thank you. Welcome back to the second panel of this session of the Clean Energy Transition Partnership Transition Initiative number 1. I will immediately give the floor to the moderator of this second panel, Mrs. Chiara Gandolfi from RSE. She is project manager in the Department of Technology for T&D. Chiara, the floor is yours. Thank you.
Thank you, Michele. Good morning, everyone. First of all, thank you to the 4 panelists that are now connected. Please turn on your webcam. I think that we are missing one. Okay, so thanks to these 4 panelists, we have 4 different points of view about medium voltage and low voltage DC distribution grid. As we said in the first panel, surely the experience and the discussion about HVDC can be the starting point to evaluate how to improve the integration of this distribution grid into the AC. The important thing is that the target for the renewable integration and a lot of the loads that we usually use are that can be directly connected in DC. This is why MVDC and LVDC are coming more and more interest. In particular, we already have some solution about this grid. In fact, the first question that we talk about with our panelists is the state of the art. But first of all, I would like to present the 4 panelists. So we have Alfredo Cota, that is a PhD researcher by Politecnico di Milano, and he's involved in European project INSIT EV about electric vehicle charging and traction solution. Thank you also to be here to Javier Iglesias from Hitachi Energy. He is a global product specialist about MVDC grid and solid state transformer. Then we have Tero Caipia from Zero Earth System. He is involved in the International Electrotechnical Committee system about LVDC, and he also in the temporary working group about LVDC, organized by European Commission and the set plan initiatives, with the aim to join this temporary working group with the HVDC working group in set plan. And last but not least, Enrico Ragaini from ABB, that is in charge of innovation project in low voltage device and application in ABB Smart Power R&D. So thank you again to be here. And as I said, the first roundtable is about the state of the art. So for each one of you, we have different point of view, the researcher, the distribution grid operator, we have the standardization point of view, and also an industrial point of view. So please, can you give today what is already done, and obviously in the next part of the panel, also what we have to do again, because we are only at the beginning of this journey. Please, the floor is to Alfredo Cota.
Hello, everyone. Good morning. Nice to meet you all. So thanks to Mrs. Chiara Gandolfi for the invitation to this very interesting panel. And yeah, I will start with basically what concerns my research, which, as was mentioned before, is the Insight EV project, which is an European-funded project that deals with electric vehicle recharge. And namely in our use case, which is in Torino, UC4, we deal with direct connection with the tramway grid that powers the Turin's tramway, in order to provide the electric vehicle charging solution in a parking lot which is located in the southern part of the city. What we do, as I said, is a direct connection with the tramway conversion substation, and there are different types of chargers that we are developing as of now. Namely, there are 10 low power DC CCS2 standard chargers, and one ultra-fast charger of 150 kilowatts. So we can serve all the different purposes of the usual customer. And yes, the state of the art concerning our project is now devoted to searching, as I will perhaps more fluently articulate in the next part of the panel, on the regulatory side of things. Concerning, of course, a direct connection to a DC power source like it is in our case. So on the power electronics side, we are pretty much at a good point, but we need to finalize the different developments of the regulatory side. So I guess our use case works as an example of what can be done using a pre-existing DC network, as is the tramway network in a city. Many cities have, so I guess it's a good starting point to kind of discuss what can be done with the present state of the art, so to say, in order to bring it to the future. So I'm open to any sort of other suggestions or curiosities maybe. So feel free to ask and let's discuss.
Thank you, Alfredo. I think that one key point is already come out about regulatory and standardization activity. So we can consider this one for the next question. And which is the position about an industrial operator, about the state of the art of the components, of the technologies to improve the development of MVDC and LVDC. So we can give the floor to Javier and then to Enrico Ragaini, that are two industrial operator can give us their opinion.
Okay, thank you, Chiara. Good morning, everyone. Thank you for this opportunity to be in this event. I would like to share a couple of slides, if possible, Chiara.
Yes, sure.
Something to highlight the point of view of the, more or less, the industry. Let me know when you can see.
Yes, we can see.
Okay, perfect. Just following the previous comments, for sure, what we see from the industry and what we expect and what we would like to have is a fully system or partial system based on DC, because as you commented, many power sources and loads can operate in DC. Battery storage, the solar panels, data center, electrical vehicles, fuel cells, traction for electric trains operating in DC. And also very important should be the conversion between HVDC to medium voltage DC. So what we see is that there are a lot of opportunities to operate in DC, but still is not fully developed because there are many challenges, mainly in the technical part and also in the regulatory part. So it's right now not ready to have a full system in DC, but maybe could be feasible to have a system that could operate in a, for example, in a hybrid system. So we see that also it is possible to have an hybrid AC and DC system cooperating and looking for the best opportunities for each of the parts. For sure, the AC system will be there, but we foresee that for specific applications, the DC concept and the DC solution can provide a lot of opportunities and advantages. Then from the point of view of a big industry, we foresee that there are a good future for the DC, but there are still some challenges that we'll comment later in the next section. So thank you very much for the opportunity to comment this state of the art, because what we see in the state of the art is that still there are the main actors that we consider that could be the other OEMs and the utilities to speed up and to provide some technical solutions that are needed for this. And as well, another part is the standardization. So there are activities, very good activities from SIGRE and IEEE working on this topic in the DC, or in the equipment and as well in the operator of this equipment. But still we are in an early stage of all these activities. But in any case, we expect that this will be improved in a very short time. Okay. Thank you very much, Chiara.
Thank you too. Thank you too. So please, Enrico, what do you think about this?
I can add something to what was said. I start from a low voltage perspective, and then also I can extend to medium voltage. Basically, we have the building blocks that we need for most of the functions. For example, converters, we have, I mean, there are in the industry and there are many producers. Also, other devices like circuit breakers, for example, for DC. In low voltage, we are already in an industrialization phase. Maybe there is some more work to do on medium voltage, but they are arriving. So, I mean, from the point of view of building blocks, we are there. On the other hand, there is, as we will see talking about the open points, there is a lack of system concepts and system standardization. Behind the meter, or for the user plant, there are some attempts of developing some industry level standards, like current OS is an example, or DC industry is another example. But for the grid, this is less developed. But I would say that the devices are there. On the system level, there is still some work to do. We are not yet at the tipping point.
Okay, thank you, Enrico. Yes, as we said, we have different topics, the standardization technologies and also the system approach. About this, I think that Tero Caipia can give us some position about the system committee LVDC, because as you know, in the last years, this point about the importance of the system is in charge of a lot of operators.
Yeah, thank you, Chiara, and hello everyone. It's nice to be here and joining this discussion with you. I want to react immediately to what Enrico just said about the need of system level standardization from the DSO's perspective, and that's actually, I would say that that's the main focus of IEC at the moment, the systems level standardization. So it has been started, but as you know, standardization work takes a time, and especially at the IEC level, it takes time. but that's the main focus, and that's what SIG LVDC, the System Committee for LVDC, is doing, and collaborating with other system committees and the TCs at the IEC level. And if we look TCs at the IEC level who are doing this kind of a system level standardization work, for example, TC8, there are already projects going on of the system level standardization from the public distribution perspective in the working groups of TC8, in collaboration with SIG LVDC, of course. But then if we look installation levels, of course, TC64 has already published many documents that deal with LVDC in buildings, but they are also looking the interconnection, the interface to the public grid, because that's important both for the public distribution and for the installations in buildings. So that's where TC64 is also doing such a systems work that is, to me, relevant also for public distribution. Well, as I said, already at the IEC level, there are many activities. Now there are also these many other activities outside the IEC level and CENELEC level and the national committees like SIGRE or the current OS that was mentioned, or the DC Industries project. Somehow, at some level, I would say that we also have a little bit too many overlapping standardization activities or some kind of activities that try to drive towards standards. There are too many overlapping going on, and it's difficult to coordinate the work. And at the IEC level, we are even in some places we are facing the situation that there are so many proposals, new proposals coming all the time that, hey, this is a good system, then this is a good system. We need system information, that's correct. In standardization, we need, and that's what we are trying to do now, to collect use cases and the technical specifications of whatever systems are used in those use cases, and of course also the equipment. And that's important work. So I believe that at least some of you who are here today are already familiar, for example, the online questionnaires that we have opened at the IEC level to collect this kind of use case and technical system information. And everything that you can contribute is very welcome. And then we go to the product standardization. As Enrico already said, there are a lot of products that are usable, are suitable. They're already in markets. There is already a lot of product standardization in place and has been in place already a long time, because DC has been continuously used in industry, for example, and is more and more used, of course, in other applications too, of course, PV and EV charging and so on. Those are the new ones, but we have to remember the long history. DC never went away in industry, even though that it went away in public distribution. And that's why we already have a lot of product standardization in place and the components available that can be used also in public distribution. But of course, the product standardization itself, it also has to evolve, but it can only evolve in a correct manner if we first do the system level work. And that's why I totally agree with Enrico that the system level work is important. And what we need at the IEC is that we need this properly formulated information of the use cases and systems. And of course, we like to listen and talk with all of these other organizations who are trying to drive standards. That's a good thing. But we also have a little bit try to manage the overlapping, because each and every one of those organizations or advocates is, of course, thinking that their idea is the best. But at the IEC level, we have to and try to combine everything. Okay, but that's, I think, enough of the standardization. If I say just few words of the state of the art of the use of public LVDC distribution. Well, that's what our company is all about, zero hertz systems, and we have we have delivered installations in Finland for public utilities, so pilots have been done, and there is already a lot of experience on how to use DC in public distribution. And everything, all of this has been possible because of the industrial history. And the fact that, for example, in Finland, we already have long had those kind of national rules how to build DC installations. And now, because the component availability is good, as Enrico said, we can do those installations. Later on, if you want, I can show maybe some photos or something, but I think that this is enough now. Thanks.
Okay, thank you, Tero. So sure, the idea to have a system approach can be also used for the proposal for the call, for example. So we can have a pilot or a demo with all the operator involved. So the researcher, the industrial partner, and the utilities. Another important thing is we have a lot of open point. In these 10 minutes, we heard different open point. For you, which is the priority? So the system approach is clear, but inside the system approach, which is the main use case, the main element to be considered? For example, Alfredo can talk about the opportunity to connect electric vehicles, so another kind of use case for DC. As we said from Javier, a lot of power generation, but a lot of loads now are in DC. So starting from this experience, Alfredo, please can give us some open point to evaluate how to integrate better in DC this kind of loads, power generation and load together.
Yes, our use case, again, just to give an example, takes into consideration the possibility to integrate eventual generation sources and also electrochemical accumulation systems for balancing the various loads that a tramway grid actually has to sustain, in its functioning. So this just on a simulation level, though, so we're not working actively to actually do something in a practical sense, but just from a theoretic point of view, we are trying to figure out how to integrate this sort of other components and pieces of the puzzle into a systemic approach, as we were stating before, because I think that after many thoughts and potential reflections on these topics, we still have to get to the point of the systemic approach and also the regulatory issues that we can have. So I guess these are still the most important points in the discussion, because as previously mentioned, from a technical and technological point of view, I guess the pieces of the puzzle are already there. But in order to make everything gel together in a proper way and with a systemic approach, you need to have also the enabling power from the authorities in order for it to be on a larger scale. I, of course, coordinate just an European project. So on an experimental basis, you can, play around and, in all the gray areas that you can find, because that's what innovation is all about. But at the end of the day, for larger scale, applications, you cannot actually have an impact without previously, stimulating and getting answers from the authorities that most of the time actually have not thought about that sort of scenarios, and they don't have any answers. So you also have to provide them with potential solution and future scenarios in which their own effect can be actually positive for the widespread of all these technological solutions. So that's again the contribution from my experience of a small project coordinator. But I guess we all come again to the systemic side of things to actually have work to be done.
Thank you, Alfredo. And in your few words, you talk about simulation. To make a link with the panel number 1 about HVDC, also in this case, simulation, hardware in the loop simulation are very important because, as you said, we can't have directly a pilot in a real field, but we need a lot of steps to be more confident about the opportunity and the controllability and the efficiency of the system. Connected to these elements, one key that we already don't talk about is controllability, manage of different sources. So we need the coordination about, for example, different partners, stakeholders, but we need coordination of the different building block of the system. So which are the open point about the control, new tools, new software, new planification, evaluation to make this distribution hybrid HVDC be real? Please, Javier.
Yes, thank you for the question, Chiara. Can I share one more slide?
Yes, sure.
Okay, just I would like to highlight this slide. Let me know when you can see.
Yes, we can see.
Okay, thank you very much, because this is very important. Following the comments from Alfredo, what are the best options to integrate and to start to develop the DC? Well, one of the important things that always we see from our point of view is to have, if possible, an overall vision of the system. So one of the challenges that we have is that, for example, in Europe, we are talking about a lot of different distribution companies, hundreds of them. Even in each country, there are several distribution companies. So each of these companies typically has a focus area in which they operate. And then in many times, coming from the heritage, from the old power system, there are several voltage levels, etc. So it's difficult to look for a general application or maybe some general rules. This is one of the activities in this regularization and standardization committees, so, which is very important. So the way how the DC could integrate all these possibilities based on different power sources based on DC and as well loads based on DC could have different approaches. For example, as Alfredo was talking about, one of the options could be, for example, connecting electric vehicles, also connecting renewable plants, for example, with solar panels that operate in DC, also combining with battery storage. And then this can be partially in the system. It is connecting the specific loads or power source. But we need to think, for example, in the overall system, how the utilities they expect to invest in the future years and to integrate all these possible DC grids, combining the best optimization of the DC capability. So this is the big question: how they will integrate all this, and how do they will operate this, integrating a lot of power converters and electronics. This is one of the main challenges that we see. How the utilities will face this challenge? Are they going to invest a lot of money on this, as is theoretically expected from all the expected consultant analysis, or not? So based on that, could be several speeds in the integration of DC. But I guess that the first possibility to integrate the DC is looking for specific applications based on DC power or DC sources with loads or not. And then after this first integration, when the companies are fully confident, should be possible to expand the utilization of the DC grids. Okay. So thank you.
Thank you, Javier. So as we said, as Enrico said before, we already have some building block, but from a technological point of view, which are the next step? Which are the main components that we need to test, to analyze, to simulate for LVDC and MVDC?
Well, I guess for LVDC we have a lot of components, but we need to do the jump to the medium voltage DC. We lack yet the medium voltage direct current circuit breakers. There are a lot of activities and research centers working on it. There are some possible solutions from some companies. Also, this is related to the component for the circuit breakers, but we need also to develop the power converters to connect the low voltage DC with the medium voltage DC. And this is another big challenge. How will be the jump from low voltage to medium voltage, and what components will we have? Will we have DC to DC isolated converters with solid state transformers? Will we have only AC to DC converters, not isolated, connecting several areas, but very limited to these areas where the utilities want to connect DC loads or sources? This is still yet to be solved.
Okay, thank you, Javier. Now, what do you think, Enrico, about this?
Well, first of all, as a general comment, the electrical grid as we know it has been developed over more than 100 years. Now, what we are doing is we are trying to make a very deep change and develop something pretty new, but we want to be much quicker than that. And then maybe one difficulty we're facing is that we are pushing hard to speed up. If we just allow, or if we could allow time to settle up, maybe we would not face so many issues. But anyway, so apart from what was mentioned already, that we miss standards and regulation, and let me comment that the purpose of standards and regulation, in addition to making devices work, is also to protect investments from companies. If you have to develop a product or if you have to set up a production line, of course, you want what you do to be usable. And if there is no standard, or the standard is fuzzy or fluffy, then maybe you are uncertain, and then maybe you delay the investment and you postpone everything. So apart from that, I would say the system aspects and system behaviors are the ones that we still are missing some work. For example, how would we ensure good behavior of many devices? It's easier in a way to have one device comply and be well working, but then what are the requirements for each device to be a good citizen when you have hundreds of them, and each of them can do different things with different algorithms and different controls and different. So these system things are the ones that we probably are still missing. Another thing is that the existing grid was built from scratch because we didn't have an electrical grid beforehand, and now we have. But what we are doing now is we are working on an existing grid. So we will have a long period where we have hybrids or retrofit activities and the hybrid network, in which some parts will be AC, some parts will be DC, and some installations will have both. So this is something that will make things in a way more interesting, and in another way more difficult to handle. One additional thing I would like to mention, that in addition to technology and in addition to standards and regulation, what we are missing, an open point, is education. I mean, technical education and expertise, engineering capabilities. If you want to design a building with AC, you can probably find hundreds of engineering institutions that can help you and do a turnkey project for you. I do a shopping mall. I go to somebody and I say, okay, design the shopping mall electrical installation for me. Now, if you want to do it in DC, it's very hard to find somebody who can actually design and follow the projects. The more difficult, the more the project is large. If you have a household, maybe you find somebody. If it is a large building, then it's more difficult. If it is a part of a city, then it becomes impossible. It's very difficult because we don't have the experts yet. Because it's new, we don't have enough engineering experience so that this can be done in a standard way. So every time, in a way, it's difficult to find the expert or the consultant and so on. So this is, for me, one of the big open points here.
Okay, Enrico, thank you. And about your sentence that is in our already development country, we already have the main grid, so we talk about hybrid. One important point is to use the DC grid for the new development countries. For example, we have a lot of countries, for example, India or Africa, where the DC grid can be the way to give the access to the electricity to some people. In this way, I think that the standardization is important, because otherwise we have some countries with a DC grid from scratch, and so they can do everything they want, let me say. But in reality, this component, this solution, then can be used also in the other countries. So we think that about the development country, we talk about hybrid AC-DC grid, but in some cases we can see the DC grid as the only main grid that we can have. And then a last thing to Tero Caipia, some comment about this, and also the position, the operator about the open point, and also a sort of suggestion to who would like to participate to the call of CETP, to underline what you would like to do if you propose a project for this call. So which can be your title for your project proposal for this call.
Okay, thanks. First of all, I can a little bit react to the other people. I think that was a very good point, Enrico, that you made about the fact that we already have a grid now. 150 years ago, we didn't. And that's an important thing. And the change will never happen overnight, especially when we are talking about public infrastructure. The public infrastructure is never ready, as you know. It's continuously evolving system. And now we are just bringing the DC into the pool of development of options or evolution options. And then it finds its place, I would say. So now it comes there, and then eventually it will find its place. Personally, I think that we will be living in the hybrid world from this point forward forever. We are already living in the hybrid world of AC and DC, and personally, I don't believe that the AC technology would go away completely. I don't think so. So there is so many good points in AC too, so that they both have their kind of the best places where to use. Then I go back to beginning to Alfredo. You mentioned the regulatory things, and development of regulation is of course, to me, it's important, and we should look regulatory issues. The one thing that where I would start, especially on the European level now. If we look globally, it's difficult, but in the European level and the EU, we have the possibility to harmonize. And currently in Europe, we have the situation where there is a lot of national regulation. In some countries, there are even regulations in place that are direct obstacles for implementation of these. Whereas in some other countries, there are not. For example, in Nordic countries, there's nothing in the regulation that would prevent use of these. We need to harmonize. And it means that we also, in some countries, we need to get rid of some old regulations. And that's, of course, always a difficult thing, because then you are talking about politics, and then you are talking about legislation. But that's something that I think that must be done. So I think that you're absolutely correct, Alfredo, in that. So harmonization and getting rid of the regulatory obstacles. And let's not write more regulations. We don't need to regulate at the legal level every technical thing. That's what standardization is for. So we need to keep that in mind. Of course, there is also room still for technological improvement. Even though that we have the building blocks, we can always improve the building blocks. And if I would personally look at what are key points for research in technical side, would be to focus on the converters. We will have a lot of converters when we implement DC. And converters currently, okay, converters are fairly efficient. But if we look public distribution, the behavior of loads in public distribution is completely different than the behavior in industrial applications or even building installations. And it means that it's a challenging load behavior from the efficiency perspective for the converters. So all research that focuses on how to improve the efficiency of converters needed in DC, whether they are DC, DC, AC, DC, or DC, AC, whoever cares. But in general, the conversion technology improve its efficiency and reduce its cost. Those would be, to me, kind of the main targets for the technological research. Someone was talking about, or maybe it was Javier who mentioned about the actual converter setup, that whether between MVDC and LVDC, whether it's galvanically isolating or not. Well, if I take something from the discussions at the IEC level, at least there the feeling is that the main rule is that you should have a galvanic isolation between medium and low voltage. But of course, there are limited applications where it could be maybe possible to leave that out. But then you go back to the business ideas and thinking that whether it's reasonable to have two kinds of products or not, if you can do everything with one product. Still staying the technical level, but now going towards more the interoperability question. That's an important question to solve. And from standardization perspective, it always means EMC standardization. Because interoperability is basically part of EMC in general, even though many people think that EMC is just some high frequency stuff. It's not. It's compatibility. And interoperability is part of that. Standardization, we of course work in a little bit different level, but that links this interoperability question also back to the regulation. Today we have regulation regarding interoperability of different sources and loads for the power system, but those are written for AC only. We need similar ones for DC too. And everything has to be then, of course, in line with the EMC standardization that continues further from that point, and eventually goes to of course, to the product standardization. But anyway, those to me are kind of the main points for the research. Is what we should be looking at in the research. And the final and the last thing that I want to say is that I think Enrico said about this capability for building these installations and operating. And that's true. There are only a handful of consultancies, for example, who are today capable of designing your DC installation. But that's an education question to me. We need to educate engineers so that they are capable of doing it as well as they do it in AC today. And then we also need tools for those. And if I now look from a DSO perspective, I'm not aware that there is a single distribution DMS system that is capable of calculating an actual DC installation. Many of those can calculate the DC power flow, for example. There's nothing wrong. But when you throw in the converters, the actual products, it doesn't work anymore. So we need to develop the calculation tool for the DSOs and engineering consultancies who are planning and designing these installations and networks. Probably that is not so much of a research question. To me, it's more like a product development question in the software side, because everyone knows all the physics. But there is a link to the standardization, and especially the product standardization, is that when we have this kind of a calculation software tool, there are limits that the tool needs some parameters. And regardless of the manufacturer of a converter, for example, must be able to provide the same parameters for the engineer to put in that calculation tool. So we need to take that into account in the standardization development, in the product standardization for converters for DC applications. Okay. I don't know whether there was enough or whether my list was too long.
Thank you, Tero. I agree with you fully. I also would like to highlight, as you did, we need good models for the equipment, for the converters, and we need to run system studies to demonstrate the proper operation of the system with DC, to demonstrate to the companies that there is no issues with the grid stability, with the transient stability. See? Also, it's very important for us that the companies apply resources to this, because also the integration of the DC converters in any of the type, isolated or not, for sure they will have an impact in the operation of the system. Right now, the grid operates as a passive loads with transformers, loads, etc. As soon we introduce power converters and electronics, these systems are active components. They will operate in a different way. So we need that the companies are interested to work in the communication, the control, the protection schemes that will change for sure with this new equipment. And then also for sure, we need to think that it is necessary to look for the cost competitive solution. As you say, you can have a beautiful converters that can solve a lot of things, that you can communicate with digital controls, etc. But if it is so costly that it has no business case, so it will be difficult to integrate. This is more or less 3 key points that needs to be addressed in the future. Thank you.
Thank you, Javier. And only 1 minute to give the floor also to Enrico and Alfredo to conclude their participation to the panel. Thanks.
Okay. Just my last point would be, because the aim of this is also to say which would be potentially interesting problems to work on or projects to present. So in my view, if we do some system study, this must go together with some either demonstrator or pilot, or call it a sandbox if you want, where you can test real devices in a realistic condition. So what we call the technology readiness level, I don't know, 7 or maybe 8. So things that are very, very close to reality, where we can try things and see how they work together. So that would be a very interesting setup for me. And the other thing would be education project and increasing knowledge about how to design, how to deploy DC network. That would be my preference if I had to do it.
Thank you.
Mr. Ragaini completely stole my points. So I really agree. Whatever you would like to propose as a proposal, sorry for the repetition, in the future, just make it as feasible as possible from an implementation standpoint, with an eye for, as Javier Iglesias mentioned before, also the business cases that can be sort of matched to this sort of innovation. Because otherwise, it's nice, it's very interesting, but it's not so fruitful for the development of society in general, and more specifically into this sort of network improvement that we are searching for. So just aim for the more practical things as much as you can.
Okay, so thank you to all of you, and I think that we can expect a lot of good project proposal, since the idea are enough. And thank you also to Michele and colleague to give me the opportunity to be here, and good job to everyone.
Thank you very much.
Well, thank you very much.
Thank you very much. Thank you.
And thank you
very much
also to the panelists. I think this has been quite an interesting working session. I think that both panels have given the panorama and very, very precious insights to the potential proposers to our call. There has been a lot of information shared, and I think that among the different gatherings, this has been extremely insightful. We have looked at different voltage levels, going from ultra high voltage down to the low voltage. We have looked at technological aspects and needs. We have discussed about regulatory needs and regulatory open points. We have discussed very much about standardization needs and the very, very key aspect of interoperability. Very much, mostly in the medium and low voltage application, and the low voltage, application. We could discuss about real application and real world in terms of test trial, in terms of living labs, in terms of also sandboxes. And we have also covered quite an important aspect that is also education. So I think that in these two sessions, we have really covered the main, we can say, flavor of the Clean Energy Transition Partnership Call 2023 on DC application along the three levels. So technology on the one hand, but also market and adoption on the other hand. So I am absolutely sure that the audience has much better ideas where they can apply their skills, where they can apply their resources, and which can really be the key point that the different proposers can really touch upon. But the devil is in the details. So there are aspects that you in the audience absolutely need to know. Is the procedures and the funding ways and mechanisms that the Clean Energy Transition Partnership has set up for you. This is for the technicians, for the researchers, a little bit less exciting than voltages, currents, and bits for communication, but it is absolutely essential for the achievement of a successful proposal. We have the chance, we have the opportunity of having with us the representatives of the coal management group in the Clean Energy Transition Partnership, Maria Enge and her colleagues, and she will tell us all what is needed, and also ICO is there. They will tell us all that you need to know to have a proposal that really is successful, not only from the technical point of view, but also from the funding mechanisms and from the call respect to the call procedures. So, Maria, I will give you the floor. You have got about 15 to 20 minutes to show us everything that we need to know about the aspects of funding. And of course, we will then open for 5 minutes of question and answers. The floor is yours. Thank you very much.
Thank you. So we are from the call management of the CETPartnership. We are situated in Norway at Nordic Energy Research. And my name is Maria Enge, and my colleague Aiko will start, and our colleague Ragnhild will also speak a little bit about the platform. So we hope we will do it not too long, because we were planning for 30 minutes, but we'll see. Go ahead, Aiko.
Yes, thank you, Michaela and Maria. I'm Aiko Hirande, working with core management in CETPartnership. I hope you hear me and see my screen. Yes, thank you.
Yes, we can.
Yes, we can. Perfect.
Yeah, good. Now, I and my colleagues at core management will give you an overview of the joint core 2023. Joint core 2023 has a total core budget of over 127 million euro from almost 50 national and regional funding organizations, plus additional funding from the European Commission. Funding organizations fund legal entities based in their country region, and they make funding arrangements directly with project partner in funded projects. Please note that different funding organizations have different national regional requirements and fund different core modules, which you can see in the annex in the core text, Annex C in the core text. If you have any question about national regional requirements, please contact the funding organization in your country region. Little more detail of the funding and reporting here. Each project consulting partner, which you see in the down part of the presentation, they will have a grant agreement with a funding organization, which you see in the upper part of the presentation, in its country region. And they do reporting to the funding organization and receive payments from the funding organization. By the reporting between the project consortium partners and the funding organization, the project consortium will do reporting to the CETPartnership, which receive funding from the European Commission. Project consortium must be built to submit the proposal and may consist of a coordinator who is a legal entity participating with funding from the core and is responsible for coordinating and managing the project. The coordinator cannot be changed after the deadline for the proposal submission and before the funding decision in core process. So the core consists of the two stages, proposal stage and full proposal stage. I will explain a little more later on. And the project consortium may include also beneficiary partners, or must include beneficiary partners actually. Beneficiary partners are project consortium partners participating with funding from the core. It means that the coordinator is one of the beneficiary partners. And in the project consortium, there must be at least 3 beneficiary partners, including the coordinator. Project consortium may also include self-finance partners who participate from any country with their costs declared, but without applying for the funding in the core. They submit letter of commitment at the first proposal stage in the core. So all these project consortium partners must be listed in the proposals and sign a consortium agreement at project start. project consortium may have also associate project partners. They participate from any country without declaring their cost or applying for funding the call. They don't need to be mentioned in the proposals, and they don't submit any letter of commitment. So the self-finance partners, associate project partners is similar, but self-finance partner, including a project consortium, they should sign a consortium agreement, should be mentioned in proposal. Associate project partners, they don't need to be mentioned in the proposal, and they don't sign a consortium agreement. It's a difference. And for the project consortia, there may be specific core module and national regional requirements. So please read carefully the core text. Between the proposals and the full proposal, no fundamental changes initiated by the project consortium alone will be accepted. But minor changes in the project consortium, otherwise in the project budget, applied funding may be accepted. You can read more in the subsection 6.2.1 in the context. Eligibility criteria and requirements. There are 3 levels of eligibility criteria and requirements. The first is the transnational eligibility criteria, which will be checked by us at core management. And the second is core module requirements, checked by TRIs, Michele and Giuseppe in your TRI. TR1, I mean. Then the third level is national regional requirements, which checked by the funding organization. And the eligibility check will be done at both pre-proposal stage and full proposal stage in call. A little more about transnational eligibility criteria. There are 8 transnational eligibility criteria. The part is that a proposal must be written in English and submitted on the submission platform before the deadlines, following monthly template. And the mandatory templates are available for download on the start page of the submission platform, and have instruction regarding the total page number, font type, and size, and so on. Second is a project consortium must be built of at least 3 independent legal entities, applying and deemed eligible for funding by relevant national regional funding organization from at least 3 different countries participating in the core. These at least 2 must be from the European Union member states or Horizon Europe associated countries. The third is the total effort of one project consult partner can be maximum 60% of the total project effort measured in person months. The fourth is the total effort of project consult partners from one country or region can be maximum 75% of the total project effort, also measured in person months. Fifth is CETPartnership. Governing board members, general assembly members, and researchers from the funding organization in the core are ineligible and cannot be in your project. Sixth is a project must start before 15th December 2024. The seventh is the project must finish in 36 months. from the start of the project. The last one is the proposal must include a work package for reporting and knowledge community, which is described in Annex A of the context. Here you can have the overview of participating funding organization. You can see more in the context. Yes, how to submit proposals. There may be two submission. The first is should be done on submission platform. The first stage, proposal stage, from the project consortium to one, you must choose one core module when you submit the proposal. And when your proposal goes through the first stage, you come to the next stage, full proposal stage. And you should submit the full proposal to the same core module as the first stage. And there may be another submission, which is national regional level, because some national region funding organization require additional submission on the national regional level, which you can see, read more in the Annex B. Now I expect my colleague Ragnhild show you the submission platform.
I intend to give a short run through of the platform. If you, Aiko, could assist me in switching the slides, please, as I go through, that'd be great. So you have the general registration here, where you will click the login for pre-proposal, and you will find it on the webpage address that you see in the left-hand corner. If you click the next logo, please. Thank you. So here you have two options. If you already have an existing account, you just log into that, or you register a new one, and then you will receive a confirmation link by email. Very basic. Next one, please, Aiko. And for step number 2, you will create a proposal. So as we saw in the last picture, you will have the opportunity to push the add button, and here you will fill in the information about your proposal. The general information will come first, of course, such as title, name, etc. Please, next one, Aiko. Running through this very fast for you. And then here you will be able to see kind of your status of submission. If we can take the next slide, I think that will be a better one too, Aiko. So there we go. Yes, perfect. So here you can see the status of the information that you have filled in. And when you click open, you will just simply fill in the information on your project. And you will also invite your partners this way, and they will receive a link where they also can log on to fill in the data you will see on partner data/coordinator. And so, yeah, next one, please. Perfect. And then, yes, the partner will simply fill in you will fill in the information of your partner and invite them. As we see, I think I'm a bit ahead, so please, next one. Perfect. And you can see who is the coordinator and who is the partner on the bottom line of the page. Each kind of column will have explanatory steps, so it should be very easy for you to kind of follow along if you don't really catch what I'm saying at the moment. So next one, Aiko, please. So the inviting party will get an information via mail. Simply click the link. And next one, please. Aiko. Yes. And just perfect. And then they will add their application in. Same formula as you probably do as projects. And then the next one. And then you have the possibility to accept or decline when someone invites you for their proposal. Next one. And then you will fill in here, as I previously mentioned, your partner data. And you will see the status of your proposal and your partner data, which is now currently in progress, but that should be fulfilled when all is done. The next one, please. Let's see, fill in proposal, yeah, went through that. Next one, please, Aiko. Yes, and you will also have a column on the left-hand side where you can kind of see which is the next step for your application. And yes, I think we can jump to the next one here as well. Oh, wait, you have the PIC code, which is a code you need to have. You will find the link there where it says participant register PIC. It's at the EU Commission side. You can also check if you already are registered, your organization. If you already have a pre-existing PIC code, you will be able to find that on the web page, or else you can register your organization through that web page and then come back with the PIC code where you will fill it in here. It's very necessary to have that. And the next step, please, Psycho. Validation and submission. Here you can have a preview of all the information and check if everything is all right. You will get notifications on the top of the screen if there's anything missing or lacking. And you can also see here required fields missing, where you have details over what you need to fill in. Next, please, Psycho. Yes. Again, yes, you can see the preview here. And if you have any issues, feel free to contact us. You will have our information, as you see here down in the left-hand bottom. So just give us an email or click the button for IT support if there's any issue coming up. And now I think I will give the space over to Maria, my colleague. She might also fill in if I missed something. Thank you, guys.
Maria, you are muted.
Yeah, so thank you, Ragnhild, and thank you, Michele, for noticing. So that was a quick view of the proposal submission system. You will probably find it easier to compare when you have it in front of you, but we wanted to show it just to have seen it before. So now I will speak about the evaluation, which takes place after the deadline of the pre-proposal in November 22nd, and also after the full proposal in March next year. So as I said, first there are this the eligibility check that I could describe, and it's different levels. It's the CAM doing the transnational, the TRIs doing the call module eligibility, and funding organizations for the national original requirements. And for those that are fulfill the transnational eligibility criteria, they will go to the evaluation. And that is performed by 3 independent evaluators. And as you see, following the Horizon Europe evaluation criteria, excellence, impact, and quality and efficiency of the implementation, which all 3 of these have scores from 0 to 5, full scores. And we're combining these 3, adding these 3, there is a cutoff for being able to get funding. That they are cut off if you're below 10 in total or below 3 for any of the 3 criteria. Then you will not be able to get any funding at all. This evaluation will result in 1 ranking page per call module, so that we don't put it together. So there will be 12 different ranking lists. So next slide, please. So there are, as I said, similar, it's the same criteria as Horizon Europe, but there are some small differences in the sub-criteria. So the first is the project objectives pertinence and how ambitious and beyond the state of the art the project is. And here it's important to remember to check the call text and the call module texts, to have that in mind when you write it, and also to see if it's a research-oriented approach or an innovation oriented approach, and also what ambition and positioning the TRLs you have in your project, to show this first as an overview in the pre-proposal and more detailed in the full proposal. And regarding these issues, you have more details in the call text in chapter 4. So the second sub-criteria of excellence, it's about the methodology and also a lot interdisciplinarity and cross-cutting issues. And this is the cross-cutting issues is very important for the CETPartnership and can mean different aspects and different areas and different stakeholders. And it's important to have this in mind when writing your proposal. Here there may also be different requirements for different call modules. So have a look both in chapter 8 about the call modules, but also in chapter 4 about whether more information about cross-cutting issues, gender, and open science, for example. We can take the next slide, please. Then we have the impact criterion. And first, it's about the expected outcome and impact and the added value of transnational collaboration. And the transnational collaboration is very important for the CETPartnership. So this is something you really need to focus on. And then the credibility of how you achieve the outcome, of course. And the second is how you measure the outcome and impact and how it's shown in the dissemination and exploitation plan. And the third criteria is specific for the CETPartnership, that it is the extent to which the project is relevant for the energy transition, which is of course of interest for the CETPartnership. We can take the next slide. So the third criteria, quality and efficiency of the implementation. Here, the first sub-criteria is to show the work plan and assessment of risk and efforts in the project. And you should here describe the work packages you plan to include, even in the pre-proposal, but on an overall level, of course, not so detailed. But you have to include the mandatory reporting and acknowledgement community work package, which I mentioned before. And you have more information about this in the Annex A of the call text. And the second sub-criteria is about the capacity and roles of the participants in the consortium and how you bring the necessary expertise together and what synergies that you get from bringing those different partners together. So you describe the whole collaboration here. I think this do we have another slide, or was this the last one? No, yeah, the timeline, in short. We have had Info Day some weeks ago, and you can find information from that if you are interested. We will have a Q&A session on our annual conference, 25th of October. And the pre-proposal stage close 22nd of November, and will be finished evaluation, everything end of January. So the full proposal stage is opening the 25th of January and then closes in end of March and the funding decision end of June, so that the project can start during the autumn with the last date of end of December 2024. And you have, in the meantime, you can go and have matchmaking, find your partners, find opportunities on B2Match platform. There are more similar events to this, and there may be also national and regional events, which could be very useful to attend, because then you get more information about the national guidelines. And you may also, as we have said several times today, you have to maybe submit a proposal to your national or regional organization to be eligible for funding. So that is very important. Check it up with your organization. I think now we are at the end of the presentation.
Thank you very much, Maria. Thank you, Aiko and Ragnhild, for your presentation. I would say to the potential participants that yes, this last part may sound or may look a little bit complex, but do not worry. The things are manageable, and they are very much in line with the level of, we can say, complexity of a normal submission to Horizon Europe or the other European calls to which each of us is used to. Of course, there are specificities, and thank you very much to Maria, Aiko, and Ragnhild for having shown also the specificity of this call and the platform that needs to be used. So I think we have a clear picture of the potential subjects and of the procedure to be followed. I would take also the message from Maria to check with the national funding agencies. You will see the list of the national funding agencies in the call text. So this is your Bible for this call. The call text is available on the different platforms, we can say, or at least from the links from the Clean Energy Transition Platform website, the matchmaking, and all the different instruments that are available from the Clean Energy Transition Partnership. So while I have my very important colleagues here, I would ask the audience if there is any specific question on the call management and the doubts you may have in the technicalities for the preparation of your proposal. I can give 10 more minutes or 5 more minutes if there is any specific question to be asked. Otherwise, we can close the session. Is there any question from the audience, more specifically about the call procedures and, of course, the eligibility criteria and things of this kind? 5, 4, 3, 2. Yes, I see a question. Fabrizio.
Good morning, everyone. Good morning, Michele, and congratulations for the excellent presentation. I really enjoyed it. And
thank you, Fabrizio.
That was really interesting. I was really curious to know about the call because the topic of DC, particularly for medium voltage, low voltage, is really challenging. And I think that you know inside that we are working a lot on the topic. So I think that I will promote the call in the silent community. That's but anyway, just the question. The question is about during the discussion, it emerged that education is one crucial point for DC in the medium voltage and low voltage particularly. Is it possible to include education work packages in the call? Is it allowed or is it only for research? Because normally education and research are quite separated. So that's the question.
Thank you very much, Fabrizio. From the TRI aspects, from the transition initiative aspects, I would say this is the capacity building is something of high importance. I would personally say that this can be, in my point of view, part of a proposal. But I don't know if from the call management there is any specific barrier to this, or if this is generally allowed.
It's more from the national regional funding organization, which may have a requirement, not from core management.
Good, thank you very much. So Fabrizio, I think the question is reverted to the two ministries that are financing this call. I would say that as far as there is the Ministry of University and Research, I would expect that there may be some good news for also the inclusion of skill management and capacity building.
Yeah. Anyway, thank you very much. The answer is very clear now. That's it. Thank you very much.
Thank you very much to you, Fabrizio. Any other questions? No, I don't see any additional hands raised. And then I would take the opportunity once again to thank you very, very much also from the call management, but more specifically, thank you very much for your participation from the to the panelists and to each of the participants to this call. I think it has been quite a very interesting working session, and we really look forward to receiving and to analyzing your proposals. We at the TRI level are at your full disposal for any question you may have. We will forward also the question to the call management or to the other structures of the Clean Energy Transition Partnership if there is any. So we really look very much forward to receiving your input and your contribution. We are. You can reach us at the address that you have seen also in the presentation, but which are going to be put in the chat. This material is going to be available for further consultation. And once again, let me also take the opportunity to thank very much Giuseppe Palazzo for his contribution and for being always so active as a TRI office leader here in RSE. So 12:55, I am hungry, I must say, so I will say ciao to everybody and see you very, very soon for additional initiatives of the TRI and of the Clean Energy Transition Partnership. Thanks a lot and see you soon. Goodbye.
Bye. Thank you.
Goodbye.
Thank you
very
all.
much.
Ciao, ciao.
Bye-bye.